Okay, if you guys can turn to page 29. Okay, so page 29. First up is formulas. Okay, so formulas, you're responsible for the ones on page 34, the back of the packet. I will give you distance given 2 points on the polar plane. It's on the board. And I'll also will give you the powers one, the powers of a complex number. Okay. Make sure you know multiplication and division, but really you're doing the exact operation of the name for radius, but then theta you're either adding or subtracting. Okay. I'll give you powers, and then for roots we have a specific method for these, right? You're not using this formula. We're kind of going through the steps to get to the roots. Yeah.
So the ones up there are what's going to be given?
Yep, that's right. I'll leave those on the board. I'll give you the distance and I'll give you the powers. Power is the z to the n. Yeah, and we'll go through an example where you use powers. Okay. But we want to make sure that we know absolute value, just distance between two complex numbers, midpoint. Okay, and we'll go through problems that use these. The second big thing is no calculators. So I gave you guys unit circles so that you guys can practice. I put the filled out unit circle on the back so you can practice with the one on the front. And then tomorrow I'll give you a blank unit circle, okay, for you to take with us. Okay, so today we're going to practice everything non-calculator so that you know exactly what to expect. And we'll go through each type of problem. So page 29. And in the class, I'll hand back all the quizzes and tests I'm still holding on to. So I'll give you the check-in quiz, and I'll give you back the recent quiz that you took. Okay, so first, it says plot each point given polar coordinates. So let's go ahead and find where this location is. 135 degrees, that's in the second quadrant. Okay, we're always starting on the origin, but what does that -4 tell us?
That it's -4 away.
Yeah, away, so it's going to end up in the fourth quadrant, right? So. Okay, we need to create 3 other polar coordinates that gets us to point A. So one way that we can do it is we can find a negative version of 135. So if we do 135 minus 360, well, 6 minus 3. Oh, sorry, this is 225, negative 225. So we know that negative 225 is another name for 135 degrees, right? Subtract this angle from 360, and we're still in the range from negative 360 to 360, and we're still walking 4 units away, so it'll be -4. Okay, point A is in the fourth quadrant. The fourth quadrant variation of 45 degrees is going to be 315. So we can think of it as walking 4 units towards 315. So we'll say 4, 315. And then another version, another way to think about 315 is subtracting from 360, right? So, or sorry, subtracting from 0. Or I can subtract 360 from 315. 315 minus 360 will give us negative 45. So I'm walking 4 units towards negative 45 degrees. Okay, let's try number 2 as well. Number 2, in terms of radians, so pi over 3, that's in the first quadrant. That's a variation of 60 degrees. Okay, I want to walk 2 units towards pi over 3. So there's point B. Another way to name pi over 3 is subtract 2 pi.
You always subtract to start.
Either subtract or add, but you want to make sure that whatever you get, that you're inside the interval. So if you end up subtracting instead of adding, you'll be able to catch yourself because it's outside the interval, so you know you got to go the other direction. Because if I added 2 pi to this, I'll end up with 7 pi over 3, which is too much. So I know I'm always going to land between my interval. So negative 5 pi over 3 is the same thing as pi over 3. I'm going to walk 2 units towards it. But I can also walk 2 units away from the opposite angle. So pi over 3 in the third quadrant is going to be 4 pi over 3. Or you can always add pi to get from one side to the other. So if I walk away from 4 pi over 3, that's negative 2. If I want to find another variation of negative 4 pi over 3, I can always add 2 pi, right? I'm sorry, this is 4 pi over 3. Plus 6 pi, that's going to be two outside the interval. So I have to subtract 6 pi over 3, or subtract 2 pi. Okay, distance. Let's just try number 3 here. Actually, let's try number 4. Number 4 here. Yeah.
Why did 4 pi over 3, why did that become positive?
Oh, this right here. So 4 pi over 3 is the original measure. And then, oh, sorry, this should be, sorry, my bad, you're right. This should be positive. And then I had to subtract 2 pi to get it to something that is the same coterminal angle. Yeah, okay, thanks for that catch. Okay, number 4. Now you realize that these problems most likely could require a calculator. So we'll just work it down to the point as far as you can go, because no calculator tomorrow. You're just gonna get it cleaned up as much as you can, and that will be sufficient. Okay, so let me show you what that looks like. Okay, this is my R1, R2. This is my theta 1, theta 2. One squared plus 5 squared. Now everything is going to be positive when I square it, so I'm just going to leave out the negative here. Two times R1 times R2, so that's 2 times 1 times negative 5. And then cosine of theta 2 minus theta 1. One plus 25 is 26 minus 2 times 1 times negative 5. The two negatives become positive, so plus 10. Subtract by finding common denominators, so negative 7 pi over 6 minus 4 pi over 6. So that gives me negative 11 pi over 6. Okay, you leave it in this form. Yep. Mm-hmm. Okay, let's look at number 4. Convert rectangular coordinates into polar coordinates. So this is where we have to involve our Pythagorean theorem and inverse tangent. Okay, if you don't simplify your root all the way down, it's okay. Okay, theta is inverse tangent. T over A. Let's not worry so much about the negative 1. Just think about 1, for instance. Okay, so where is tangent equal to 1? So look at your unit circle. Yeah, variation of pi over 4, or variation of 45 degrees. Right. Tangent is y over x. So the only place that y over x is going to be 1 is if they're the same. So that's going to be variation of pi over 4. So you know that inverse tangent is going to be 45 degrees. We know that's the reference angle, but which quadrant are we in?
We would have to be
Second quadrant. So we got to do 180.
So 135.
That's right, minus 45, right? We got to use it. Use the reference angle to get yourself in the correct quadrant. Okay, question?
That is all we'll have to do.
Yes, well, we got to now write it in, yeah, get into coordinate form. So it'll be 3 root 2. And then, it's asking for radian measure. So
it would be 35.
yeah. All right, 3 pi over 4 is 135 degrees, so really practice. I'll give you a blank unit circle, but you really want to be able to fill that out.
On the test, we just put root 18.
That's fine. Root 18 is fine. Or 3 root 2. Yeah, they're fine. Now, number 6 ends up not being a unit circle value, so it ends up being a little messy, but on the test, okay, I'll make sure it'll be a unit circle value so that you can get it in the, be able to find that from the unit circle and either add or subtract 180 or 360 to get it in the proper quadrant. And then you can do this if you want, do everything in degrees and convert it to radians, or do everything in terms of pi. Okay, so let's skip number 6 for now. Let's try number 7. Convert the given polar coordinates into rectangular coordinates. This is where we have to involve r cosine theta and r sine theta. Okay. This is my r, this is my theta. Okay, cosine of 210 is, yeah, cosine is the x value, okay, and then sine is the y value. Yeah. Negative 3 over 2 would be for the cosine, and negative 1/2 would be the sine. Do a little bit of cleanup here. 14 divided by 2 is 7 with a negative carried over. And just put it in coordinate form. Number 8 is the same process. It's just that it's not unit circle value. So you'll use a calculator, but on the test tomorrow, I'll give you unit circle values. Yeah.
How do you? Oh, no, never mind. You just simplify this.
Yeah, just divide the fraction 14 and 2 and get it cleaned up. Okay, let's go to the back so we can hit every type of problem. And if we have time, we'll come back to the ones that we skipped over. Okay, does anybody still need this page? All right, this is these next few problems are similar to the quiz problems that you guys saw. Simplify each expression, so I'm just going to add the like terms together. The 3 and 1 to go together. The 2 and negative 5 goes together. I'm going to draw 3 vectors, right? Got my original vector, vector 1, vector 2, and then I'll connect those dots to create that 4 minus 3i. So 3 plus 2i is going to be, well, first off, 3 plus 1 is 4, right? 2 minus 5 is negative 3. So that's easy to do algebraically. So now we'll get it into vector form here. So 3 plus 2i, I'm just going to go 3 to the right, 2 up. That's vector 1. And then from here, I'm going to pick up where I left off. I'm going to go over 1 and down 5. That's where vector 2 is going to be. So I'm starting here, and I'm ending here, so my resultant vector is just this piece right here. So let's see how far I travel here. I went 4 to the right and 3 down, and that's exactly my resultant vector.
Oh, we have to vote, right?
Yep, that's it. Yeah, algebraically, and then just graph it. Number 11 through 14 are check-in questions. So distance has this formula of we subtract the real components of the complex number, and then we subtract the imaginary components of the complex number, and then we do modulus. We just do Pythagorean theorem after that. Okay. So subtract 13 and 9, and then we'll subtract 2 and -5. 13 minus 9 is 4. 2 plus 5 is 7. And it says find the distance. So now that we have all the components, we just do Pythagorean theorem to get to that modulus. Easy enough, right? Question? Okay, we'll come back to 12 if we have time. I just want to make sure I hit every type of problem, and then the remaining time we'll go back and get some extra practice. Okay, midpoint. Midpoint, think about what midpoint means. Midpoint is the average of two numbers, right? So average is just add two numbers and divide by 2. So we're going to add the real components of the complex number, divide by 2, and we'll also add the imaginary components of the imaginary number divided by 2, and that's it. So there's no modulus after that. After you find those, after you do this operation, you're done. That's your midpoint. So 13 and 9 goes together. 13 plus 9 divided by 2. And the 2 and -5 goes together as well. 2 minus 5 divided by 2. Do a little bit of cleanup. 22 divided by 2 is 11. -3 over 2 is just -3 over 2. Okay, let's go to 15. Graph each complex number, find the modulus, the absolute value, and the argument, which is the direction, which is theta. And then write in polar form, which is RCIS theta. Okay. So -1 plus √3i, we just approximate where √3 is between 1 and 2, so it's around like 1.7. So you're going to go left 1 and up 1.7. Just get it into a vector form there. Modulus is just distance, Pythagorean theorem. One squared is 1, √3 squared is 3, 1 plus 3 is 4, and square root of 4 is 2. Argument is just theta. Theta, we do inverse tangent. But this we can find using the unit circle. So where is tangent equal to √3? Yeah. Tangent is y over x. You basically just cover up the denominator. So y over x is √3 over 1. So that's pi over 3. Or you can do 60 degrees for now. Now, which quadrant are we in? Oh, thank you. We're in the second quadrant, right? So we have to make that adjustment. You have to do 180 minus 60, which is 120. However, it says radian mode here, so 120 to pi over 3. I'm sorry that polar form got cut off. It's on the next page there, but I meant to put it at the bottom. It just ran out of space. So to get into the polar form is r cosine theta plus I sine theta, or you can put it into CIS or shorthand form. So I'll put it down here. I know you're out of space here. Okay, let's come back to 16 and 17. I think it's good for us to practice through unit circle, but I want to hit every type before I do duplicate ones. Okay, so are we okay with the process here? Again, either form is fine. A lot of students prefer the shorthand form, and that's fine as well. Just know what that means. Okay, next page. Yeah, question.
Why didn't you go all the way to 3?
Oh, it's root 3. Root 3 is like between root 2 and root 4, so it's between 1 and 2, so it's like 1.7. Okay, number 18. Actually, 18 we know how to convert, right? Just Pythagorean theorem and inverse tangent. And also 18 is not unit circle, so let's skip 18 for now. Let's look at 19. Are we okay this page? Convert polar to rectangular. That's pretty easy. You just distribute the 4 root 3 into the parentheses and just use unit circle to get it down to numeric values. Okay, what's cosine of 30? 3 over 2. Sine of 30, 1/2. Thanks. Okay, do a little bit of cleanup. The 4 and the 2 can divide out to be just 2. The root 3 times root 3 is what? Just 3, right? So it's just 2 times 3, which is 6. Rectangular form means a plus bi. Okay, let's go over each of the operations. So we'll do the product, we'll do quotient, we'll do power. So this is the formula that I'll give to you on the board. And then we'll do a root. Okay, so starting with 20. Remember, when you do product of two complex numbers, you multiply the radius, but you do what with the add. If you want to jump directly to shorthand form, that's fine. Do CIS and just add the thetas together. common denominators here. This is 8/6 plus 5/6. Which is equal to what? 13/6. Yeah. Okay, so let's write that down for now. But you're right. Yeah, 13/6 is more than 2 pi. So how can I get it into that range? Yeah, subtract 2 pi, right? So if I want to just match that common denominator, subtracting 2 pi, same thing as subtracting 12 pi over 6. So 12 CIS. Now, we don't want to resolve this, right? We don't want to find cosine of pi over 6 and sine of pi over 6, because if we do, then we're back to, we're going to go back to standard form or rectangular form. It says express using polar methods. So you want to leave the r and theta in your answer. Okay, so with the product, quotient, and power, you're not going to use unit circle values because you want to leave your cosine and sine alone. So, okay, are we okay with product? Okay, now quotient means we're dividing. So if we're dividing between Z1 and Z2, we do divide for our radius, but what do we do with theta? Subtract. Yeah, we subtract theta. Okay. Yeah. Here we are. Yeah, if we do 21, we'll be multiplying, but I want to skip down to the quotient. We're doing 22. Okay, same fractions as above. So now we'll just do 8/6 minus 5/6, which is 3/6. And 3/6 can reduce a little bit. Okay, product for 20, quotient for 22. Any questions here? So now we'll do power. Another name for power is de Moivre's theorem, but this is the one that I'll give you. This is the one on the board. Okay, you're going to raise that r to that exponent, but then you're going to multiply your n into the theta. Okay, let's try 24. It's okay if you leave it as 4 to the 4th power. You don't have to multiply all that out. Okay, what does 20 pi over 6 reduce to be? Okay, is 10 pi over 3 within our range? So we can do what? So, yep, subtract 2 pi, variation of 2 pi. Pi. So this is what, 4 to the 4th CIS 4 pi over 3. Yeah.
Wait, so where did you get 5 pi over 6?
Oh, 5 pi over 6. Oh, 5 pi over 6 was from Z2 from above. Oh, sorry. From Z2 here.
Okay.
We can leave it just with that exponent.
Yeah, leave that 4 to the 4. You don't have to work that out. Okay, so finding cube roots, this is where we have to go through our multiple steps, right? First thing is, if it's not in polar form, we get into polar form, but the nice thing is it's already in polar form. So let me just rewrite Z2 so that we know what we're working with. You want to find the cube roots. So that means we want to take the cube roots, and we're going to do what with this part here? Divide or multiply by that 1/3. Okay. So cube root of 4. Okay, do a little bit of cleanup. This becomes 5 pi over 18. So that's the first solution, right? This is the first solution. Now, how do we find the other solutions? Yeah, because every solution is going to be equally spaced around the circle. We know that a full circle is 2 pi. We're looking for 3 solutions, so we want all our solutions equally spaced around the circle. Every solution will be 2 pi over 3 apart from each other. So we're going to keep adding 2 pi over 3 to get to the next solution. But you want to find a common denominator to make it easier. So 2 pi over 3 is the same thing as what? So we just keep adding 12 pi over 18 until we reach the second and third solution. So 5 plus 12 is 17. Seventeen plus 12 is 29. Yeah, question.
On the test, will everything already be in?
You may have to, yeah, you may have to convert it into polar form. So if it's not in polar form, then you would go through your radius and your theta to get it into polar form, and then go through the root process. Okay. Okay. Let's get another practice in with this problem, because this is the one that is the most time intensive one. Yes, question.
You're just adding 2 pi, right?
Oh, you mean to get to these here?
Yeah.
I added 2 pi over 3. Remember, because there's 3 solutions, right? So I have to space out my solutions around the circle. So it's 2 pi divided by however many solutions. And it says cube root, so I know I'm looking for 3 solutions.
So the fourth one,
That's right. Yeah, so try 27, see if you can go through that process. And I'll show the answer after you guys had a chance to try that. Yeah, so these are the ones that takes the most time because there's multiple steps involved. Okay, your test tomorrow will be 10 questions, hitting one of each type. And I'll put together a test review. I'll have a help session tomorrow, but hopefully I can get that test review uploaded this afternoon, tonight, so for those of you who want to practice, can practice tonight.
Are they gonna be like this for your test? Like start off with the graphs and then get like
More or less.
someone bonus. I know it's bonus. No, but I got it. I know, I did it the hard way. I did it however I was doing on the test. I didn't use my
The only thing I said.
Okay, but what I got was like, you know, where,
Hold on.
Wait, let me see.
oh, you had. Oh, so they're already.
I calculated that.
There are different ones that for sign.
I calculated that.
I got.
Can I get a follow-up?
Right. I think Untitled, you went to bed at 5 in the morning. Untitled is like a fourth of an remember, I didn't plot on the I didn't plot on the
Yeah. No, mine was also started. I said it.
I said, I don't know, but what is yours?
I know, I got 49 so it's just minus difference. That's my one.
No, I cannot. When he just like, I
one time I went to bed at like 8 o'clock in the morning. My body did not let me get home.
They'll play poker. Wow. That don't make sense. It's poker.
You got it right.
So why'd you play?
I just did it.
I was catching crazy. Hell yeah.
Yeah, I know. I called it twice. I agree.
Charles there. Yeah.
Charles score?
Oh, yeah.
10 quarters.
I wanted 135.
Dude bleeds in.
I'm saying.
Yeah.
I know every song,
Because y'all were losing. Dude, you would have won.
You got 14 wrong too?
We got 210.
I got the same answer.
Which one is this? 36.
We're down by 2.
We're down by 2.
They're taking the ball on their baseline. They catch and travel.
Oh.
You get the ball without
How long? February.
Oh, dude, I cannot do this. Oh. No, I'm looking at this and I'm lost.
What'd you get?
Oh, 95.
Oh.
90 out of 95.
You know, this is supposed to be the next
Yeah. I'm gonna buy you one.
Go buy you. I'm gonna buy you one.
It's like the one time regarding Modulus that she assigned earlier, mine didn't.
Oh, you're